Okay, so these, I'm gonna try save some time. I'm gonna just go ahead and print the PDF for these first six. I'll just put those on Schoology so that you can look at it a little bit more carefully. These, you just need the graphing calculator. That's how all the professionals would have done something like that. So as long as you know that a log basically kind of looks like this, and then an exponential would look like this. They're inverses of each other. So that's really, I think, the thing that you really want to kind of carry with you to the end. Okay. All right. So let's go ahead then and skip to 7, and we're going to go ahead and just rewrite these in exponential form. They're already in log, so this is basically the loop situation here. So we would say 3 to the 4th is 81. And you can always let kind of common sense be your guide too. If you forget, like log base 3 of 81, how are these numbers connected? And there has to be an exponent. So that's really the best way that you can kind of figure out how these work. The loop again, I see a fraction, and so a fraction to the negative power would become not a fraction. So there's 32. This would be e to the 2.08 equals 8. All right. This right here, we're going to go the other way around so that the log base equals the exponent base 4, and that's got to equal 128. This is going to be the e, so we might as well use the ln. And so the ln of e, which is the base of 54.6, would have to equal the exponent. And then finally, this is just the log, and the log of 10,000 equals 4. Okay. All right, let's see, change the base. Oh, so this is actually, back in the day, and I think I mentioned this already, you would have to do this in a calculator in order, because there was no special button. There was only the log button. Okay, that's all you had. And so if you wanted to use a base other than 10, you actually had to do this little change of base formula. Okay, but in this case, this is going to be 0 anyway, just because 4 to the what power equals 1? Well, it's got to be 0. Okay, and then I would use a calculator right here. Let's see, what is 5? 5 to the what? 5 to the 6th? 5 to the 6th power? Let's see. No way. 5 to the 4th? It's 600. Okay, so 5 to the 4th power, but he'd have to become negative in order to flip it back. Okay, so evaluate the file. Yeah, okay, so what I'm saying is it's got to equal -4. Okay. All right, now for 12, 2 becomes 6. It's not going to be 1/2 or 2. We're actually going to have to just go ahead and find that. That would be in here. That's alpha F2, and he's right here. Just know how to find it. That's all you got to do. Okay, so that's it. That's the answer. 0.721, 3 decimal places is totally fine. And then we've got the, I don't know what's faster, log 61 divided by the log of 8, or going into that submenu. That's up to you. Okay, and that would be 7. Now, what you can do to check is just say, okay, well, 8 to the 1.977 power, there it is, 61.01, okay, because of the decimals. But that's all you got to do. I'm only going to put a couple of these. There's not a lot of math going on there. Okay, condensing these guys. So we're going to condense first, and then down here we'll expand. So let's squeeze them together. And what I do notice first is that the 4 and the 2 in front, those guys are going to go back inside. So we're going to go ahead and do a log base 3 of x to the 4th minus the log base 3 of y to the 2nd. So then, now that these guys are missing the coefficient in the front, we've put them together. We can squeeze them one more time via the subtraction. So the log base 3 of x to the 4th over y squared, and that's condensation. All right, continuing. 1/3, what we can do is we can actually distribute this so that it would be log 764 to the 1/3 plus log base 7 of 27 to the 2/3. So I'm going to put that 2 back there, but if I'm going to also put it as a coefficient in front, that would have been 2/3. So we might as well just put it in right there. Okay, so the cubed root of 64 is actually 4. Is that that's not my phone, is it? Okay, and then take the third root, that's 3. 3 to this, that's 9. What is that? Okay. All right, so now we're ready to squeeze these together. So that would be the log base 7 of 4 times 9 is going to be 36. That's your final answer. Okay. Moving forward, it looks like we've got 1/2 being distributed to these two guys. So we're going to have, I'm going to try to write a little smaller here, 64 to the 1/2 power, plus the ln of k to the 5/2 power minus the ln of m to the 4th power. Okay, so it's a little strange, but I can take the square root of 64, so that would be the ln of 8. So I'm going to just cross this guy out and put an 8. This guy's going to be multiplied, but then we're going to be dividing here. So the way this guy's going to look a little weird, but it's the ln of 8k to the 5/2, and you can leave it like that, over m to the 4th. Now the only thing that I would say is possibly, since the k is being raised to a power that is larger than the denominator, what you've got here is you've got a situation where k is being raised to the 5th, and you could take a couple pairs out. So that is a possibility of what it could look like. We took 2 of those k's out, and then we've got this guy left. So as an alternate answer, you could have had a k squared radical k over m to the 4th. Now this only happens when that numerator is larger than the denominator there, because you can grab extra pairs there. So this is totally fine, and in calculus we would just leave it like this, but just in case, I don't know, just in case it's the SAT or some other formatting, okay? Okay, so now we've got a 2 that's going to be placed in front of the, it's going to go to the power of x squared, x minus 4, so I'm going to go ahead and square that guy. Okay, because x minus 4 times x minus 4 is this, okay, plus the log of 3x, okay? So even though, you know, what can I say? It's like, could you have left it there? Yeah, maybe. I think it's better that you kind of foiled it out, because we're going to have to multiply him to all of these as well. So what we're looking at here is these two logs compressed together by multiplying by 3x. So this guy would become parentheses 3x to the 3rd minus 24x to the 2nd plus 48x. And that is completely sufficient. There's no need to factor out anything, because you would just factor out a 3x anyway. I mean, it would look just like this. Is that better? I don't know. Is this better? I don't know. It's the same thing. So if you would have left either one of these answers, I would have been fine with it. Again, in a multiple choice type situation. All right, let's stop there.